Hi friends, this is Naresh. In this class, I am going to explain about engineering drawing. And today's topic is construction of ellipse, parabola and hyperbola by using general method or eccentricity method. Before going to the problems, first of all you have to know the basic differences between ellipse, hyperbola, parabola and circle. Okay, ellipse, parabola and hyperbola are called conic sections. Okay, ellipse, parabola and hyperbola are called conic sections because these curves appear on the surface of a cone. Okay, these curves appear on the surface of a cone when it is cut by some typical cutting planes. Okay, now I will explain some examples. This is the cone, right circular cone. This horizontal line is the base of a cone. Now this dotted vertical line is the axis of the cone. Now these slant edges are called generators. Now this sharp point is called apex. Okay, apex point, axis, base, generator. Okay, these are the important terms used in cone. Now this is a cutting plane, cutting or sectional plane. In case of ellipse, the section plane cuts all its generators and it doesn't cuts the base of the cone. Okay, so this is a ellipse, the section plane is ellipse. So in case of ellipse, the section plane is inclined to the axis of the cone and it cuts all its generators. Okay, and it doesn't cuts the base of the cone. Okay, then the section plane is ellipse. Similarly, in case of parabola, here this is a section plane. The section in case of parabola, the section plane is parallel to one of its generator. Okay, and also it cuts the base of the cone and one side of generators. Then the section plane is parabola. This is a parabola. Okay, in this case the section plane is parallel to generator, one of its generator. Okay, and it cuts the base. In case of hyperbola, the section plane cuts the base and it is inclined small inclination with the axis of the cone. Then the section plane is hyperbola. So this is a hyperbola, this section plane is hyperbola. Okay, so in case of ellipse, the section plane cuts all its generators. In case of parabola, it cuts the base and axis is parallel to one of its generator. And in case of hyperbola, the section plane is parallel to axis of the cone, or it makes some angle with the axis of the cone and it cuts the base. Okay, as well as in case of circle, the section plane cuts all its generators, but the angle between axis of the cone and section plane is 90 degrees. Okay, then the section plane is circle. These are the main differences between circle, ellipse, parabola and hyperbola. Okay, now this is the common definition of ellipse, parabola and hyperbola. These are the loci of points moving in a plane such that the ratio of its distances from a fixed point and a fixed line always remains constant. Okay, here the fixed points are called focus point. Okay, fixed points are called focus points and fixed line is called directrix, and the ratio is called eccentricity. Okay, if the eccentricity is less than 1, then the curve is called ellipse. If the eccentricity is equal to 1, then the curve is named as parabola. If the eccentricity is greater than 1, then the curve is hyperbola. Okay, so this is ellipse. Here ellipse, in case of ellipse, eccentricity is less than 1. In case of parabola, the eccentricity is equal to 1. In case of hyperbola, the eccentricity is greater than 1. Now in this slide I will explain about eccentricity, the basic differences between hyperbola, parabola and ellipse. Okay, this vertical line is a fixed line, that is a directrix, and this horizontal line is axis. Now this point is called focus point. This is a fixed point on axis. So this is a vertex point. Here eccentricity is the ratio of the distance between focus and vertex point to the distance between vertex and directrix. Okay, so eccentricity is equal to fv3 by dv3. So fv3 by dv3 is the ratio of eccentricity. In this case, the distance between v3 and f is greater than the distance between dv3. Therefore, the eccentricity value E is greater than 1. Okay, in case of hyperbola, the eccentricity is greater than 1 because the distance between v3f is greater than dv3. Okay, similarly in case of parabola, the eccentricity is equal to 1. That means this is a vertex point. The distance between vertex v to f is equal to v to d. Okay, the distance between vertex and focus is equal to the distance between vertex and directrix. Okay, so in case of parabola, eccentricity is equal to 1. Now in case of ellipse, the distance between vertex v1f, the distance between vertex and focus is less than the distance between directrix and vertex. Okay, therefore the eccentricity ratio is less than 1. So this is a ellipse, this is the shape of ellipse, this is the parabola, this is a hyperbola. Okay, these three are called conic sections. Now coming to the problem, point f means focus point or fixed point. The point f is 50 mm from directrix. A point p is moving in a plane such that the ratio of its distances from focus and directrix remains constant and equals to 2 by 3. Draw locus of point p. Okay, here 2 by 3 means eccentricity equal to 2 by 3, and the distance between fixed point and directrix is 50 mm. Okay, these are the steps to construct the ellipse by using general method. Okay, first of all you have to draw an imaginary vertical line as directrix, dd as directrix, and draw an imaginary horizontal line as axis. Okay, ca as axis. Now mark focus point f. Okay, from given data the distance between focus point f and directrix is 50 mm. So this is the directrix, this is point f. The distance between f and directrix d is 50 mm. So locate the point f at a distance of 50 mm from directrix. Okay, the distance between fixed point and directrix is 50 mm. it is given in problem. Okay, now divide this CF line, that is a 50 mm line, into 5 equal parts, because here the ratio of eccentricity equal to 2 by 3. So the sum of numerator and denominator equal to 2 plus 3 equal to 5 parts. So you have to divide this CF line into 5 equal parts. Okay, that means 50 by 5 equal 10 10 10. So I divided this CF line into 5 equal parts, that is 10 mm 10 mm 10 mm 10 mm 10 mm. Okay, now name second equal part from focus. This is first part from focus, this is second part from focus. So name second equal part from focus as vertex v1. Okay, so this point is named as vertex v1. It is at a distance of 20 mm from focus and 30 mm from directrix. Okay, now draw a vertical line v1e. Okay, the length of v1e equal to v1f. Okay, the length of line v1e equal to v1f. Now draw a line. Now draw a line passing through points C and E. Okay, draw a line passing through points C and E like this. Now consider a angle 45 degrees at focus point. Okay, mark 45 degrees at the focus point and draw an inclined line through point F, and this is the intersecting point this point named as G. Okay, draw an vertical line from G downward direction like this. This intersecting point is named as vertex v2. Okay, now mark few points between vertex v1 and v2. Okay, I marked some points 1 2 3 4. There is no need to divide equal distance. Now draw vertical lines from these points like this. Okay, now with focus F as center and radius. Now focus F as center and radius equal to 1 1 dash. Okay, now you have to consider 1 1 dash as radius and F as center. Draw arcs. Okay, cut 2 arcs on 1 1 dash line. Okay, here you have to consider 1 1 dash as radius and F as center, and cuts 2 arcs on 1 1 dash line. Okay, similarly consider the F to this point as radius and F as center. Draw arc like this. Now 2 2 dash as radius and F as center. Okay, 2 dash as radius and F as center. Draw arcs on 2 dash line like this. Now 3 dash as radius and F as center. Draw arcs on 3 dash line. Similarly 4 dash as radius, F as center. Draw arcs on 4 dash line. Now now 5 5 dash as radius and F as center. Draw arcs on 5 5 dash line. Now 6 6 dash as radius and F as center. Draw arcs on 6 6 dash line. Now join all these intersecting points through a smooth curve. Okay. Now this curve is our required locus of P. Okay, that is ellipse, our required ellipse. Okay, in this case you have to remember the eccentricity is less than 1, that is equal to 2 by 3. Okay, you have to divide the distance between CF into 5 equal parts. Okay, now coming to the another problem, that is a parabola, construction of a parabola by using eccentricity method. And the question is point F is 50 mm from a directrix. A point P is moving in a plane such that the ratio of its distances from focus and directrix remains constant and equal to eccentricity equal to 1. Okay, draw locus of point P. In given question the ratio of eccentricity is equal to 1, therefore it means you have to draw an parabola. Okay, here from given data the distance between fixed point and directrix is 50 mm. Here F means fixed point, so the distance between F and directrix is 50 mm. So first of all you have to draw an imaginary vertical line, that is DD as line DD as a directrix. Then after you have to draw an imaginary horizontal line, that is CA as axis. Then after you have to mark a point F on axis CA line. Mark a point F at a distance of 50 mm from directrix. Okay, from given data the distance between focus and directrix is 50 mm, so you have to mark a point F at a distance of 50 mm from directrix. Okay, then after you have to divide this CF line into 2 equal parts. Okay, because here the eccentricity is equal to 1. Okay, so you have to divide this CF line into 2 equal parts, and that part named as V1. V1 is the vertex. Now draw a vertical line V1E is equal to V1F. So the length of V1E equal to V1F, that is 25 mm. Okay, so length of V1E equal to 25 mm, and draw a line passing through points CE. Okay, draw a line passing through point CE. Now mark few points 1 2 3 4 like this. Now draw vertical lines like this and named as 1 dash 2 dash 3 dash 4 dash. Now with F as center and 1 1 dash as radius. Okay, 1 dash as radius and F as center. Draw arcs on 1 dash line. Okay, like this. Here 1 dash as radius and F as center. Okay, draw arcs on 1 dash line. Similarly 2 dash as radius and F as center. Draw arcs on 2 dash line like this. Now similarly 3 dash as radius and F as center. Draw arcs on 3 dash line. Okay, join these intersecting points through smooth curve like this. This is our required parabola. Okay, in this case, in case of parabola, the value of eccentricity equal to 1. So you have to divide the distance between CF into two equal parts. Okay, in this case. Now coming to the another problem, that is a hyperbola. Now these are the steps to construct the hyperbola by using directrix method, directrix and eccentricity method. Now the question is point F is 50 mm from a directrix. A point P is moving in a plane such that the ratio of its distances from focus F and directrix remains constant and equal to 3/2. Draw locus of point P. Here the ratio of eccentricity equal to 3/2. Okay, eccentricity is equal to 3/2. That means greater than 1. Okay, greater than 1 means hyperbola. So you have to construct a hyperbola. First of all, you have to draw an imaginary vertical line as directrix, that is DD as directrix, and draw an imaginary horizontal line as axis CA. Then after you have to mark a point, that is a fixed point. You have to mark a fixed point F at a distance of 50 mm from directrix. Okay, from given data, F is a fixed point and the distance between fixed point and directrix is 50 mm. So this is a directrix, this is a fixed point. So the distance between F and directrix is 50 mm. Now the ratio of eccentricity equal to E equal to 3/2. So therefore the sum of numerator and denominator is equal to 3 plus 2 equal to 5 parts. So you have to divide this CF line into 5 equal parts. Okay, so you have to divide this CF line into 5 equal parts like this and mark third equal part from focus as vertex V1. Okay, now draw a vertical line at vertex V1. Okay, the length of V1E equal to length of V1F, that is 30 mm. Okay, this is from here to here the length is 30 mm. So you have to draw a vertical line of 30 mm. Now join these points, CE points. Okay, then after mark a few points on axis like this. Now draw vertical lines on points named as 1 dash, 2 dash, 3 dash. Now with F as center, focus F as center and radius equal to 1 dash. Okay, you have to consider 1 dash as radius and F as center. Draw arcs on 1 dash line. Okay, 1 dash as radius and F as center. Draw arcs on 1 dash line. Similarly 2 dash as radius and F as center. Draw arcs on 2 dash line. Similarly 3 dash. Now 3 dash as radius and F as center. Draw arcs on 3 dash line. Okay, join all these intersecting points through smooth curve. Okay, this curve is our required shape of hyperbola. Okay, in case of hyperbola you have to remember the value of eccentricity is greater than 1. Okay, now in this slide I will explain how to draw tangent and normal to the ellipse, parabola and hyperbola. To draw tangent and normal to the curve from a given point Q. Okay, this is our ellipse. Okay, first of all you have to mark a point Q on curve. So I marked this point Q here. Now join point Q and focus like this. Okay, draw a line. Now construct 90 degrees angle with this line, with the FQ line. Okay, take 90 degrees here and draw a 90 degrees line, 90 degrees inclined line like this. Okay, join a line like this. Okay, this line is tangent to the ellipse, and draw a perpendicular line to this tangent line. So this is the normal to the ellipse. Okay, so this is tangent, this is normal. Okay, similar procedure for all parabola and hyperbola sections also. In case of parabola, same procedure. Consider point Q on parabola, and join Q and focus point like this, and draw a perpendicular line like this, and join these endpoints, and this is a tangent line, and draw a perpendicular line to the tangent. This is a normal line. Okay, this is normal, this is a tangent line. Same procedure for hyperbola. Repeat same procedure for hyperbola. Okay, this is normal and this is tangent. Okay, thank you.